In this video, I'm going to talk about a Python library called JupyterCheck. Really, I'm going to be talking about a specific function inside of JupyterCheck called AnswerCheck. This function is designed to give students immediate feedback to check their answers to questions inside of a Jupyter notebook. It was primarily written for a linear algebra class to make the comparisons as robust as possible and to consider different types of objects and different types of round-off errors and things like that. So to install AnswerCheck, all we really need to do is download it from the GitHub repo. That's pretty easy. We just use this one cell. We can just copy and paste it to the student notebook, and it will grab this raw file from the GitHub repo and save it in the local directory as AnswerCheck. And the nice thing about doing it that way is that this will work on any student's computer, on any networked computer. It doesn't require installation access to get working. And so this can get around a lot of classroom problems. Once it's in, we can just run a quick check to make sure it loads and seems to be running. So what does AnswerCheck do? So AnswerCheck consists of a variety of functions. There's a basic check, there's a matrix check, a vector check, an equivalent vector check, an equivalent matrix check, and a floating check. And all of these add layers of complexity to do what you want to do. But let me just show you basically how it works. The first thing you want to do, if you give a variable to AnswerCheck, this is the variable we want to check. We want to say, let's say the answer to some question is yellow, so we set the variable f to yellow, and we pass it into the basic check. Really, basic check is expecting 2 input arguments. We've only given it 1 input argument. But the second input argument is a special hash that we use to compare the function. And so by running it without the second input, you can scroll down. The answer message actually gives us the hash that we need. So this is the hash for the variable yellow, or the answer of yellow. And so you can see we can just copy and paste that hash as the second input to AnswerCheck basic. And then when we run it again, we can see that AnswerCheck basic is correct now. And so what we've really done is we said, take the variable f, generate this magical hash string, and compare it to this hash string. And if they're the same, the answer must be the same. If they're different, the answer must be different. And this is a one-way function, right? So you can take the variable, and as long as it's the same value, it will generate the same hash. But you can't take the hash and generate the variable. It doesn't go the other way. And that's why we can use it as an answer check for classes. And the idea here is, can we get students to tell them that their answer is right so that they can gain confidence in what they're doing? But if they're not right, they can continue working and trying to debug the problems. And so this is meant for immediate feedback to give them confidence to move on. And so here's another example. Now we're just going to use a float example. And so if we take this float number, run it through AnswerCheck, this is the hash for that value. But with floats, sometimes students might calculate a value slightly differently than the instructor did. And so you get things like round-off errors. And so AnswerCheck automatically will check for round-off errors. So you can give it a different input, and as long as it's correct within that level, you're fine. And you can actually check it. The instructor can look at the documentation for float and see how that can be changed. But the idea here is to give robust solutions. So students, if they're close, they'll still get the right answer. Similarly, we have a matrix comparison. So we can compare 2 matrices, and that has the round-off error as well. And then that will give us a direct comparison. This is expecting a matrix, so if we pass it in as a list of list or as a NumPy array or anything like that, it will try to convert it to a matrix and then do the comparison, right? And so it doesn't assume that you're using NumPy, although it will use NumPy to check your answer. Similarly, we have a function called vector, which does the same thing, but for a single dimension vector. Then we have another function called equivalent vector. And the idea behind the equivalent vector is, first we pass it in a vector. And notice I pass this in as a matrix. Again, vector understands what a vector is and will check it. It doesn't care that it comes in as a list or as a matrix or whatever it is, but it will convert it to the right thing. It also doesn't care if it's a column vector or a row vector. It will convert it accordingly to make sure that the check happens. And so, but equivalent vector, what it will do is actually not only convert it, but it will normalize the vector before doing the comparison. And what's nice about that is a student can pass in any value along that vector, and it should say that it's equivalent. So just as an example, I'm multiplying A, which is our vector, by a scalar, and any scalar beyond 2, it should be equivalent, and it is. And so you can see anything should work for that equivalency. All right. Similarly, we have a concept called an equivalent matrix. And the idea behind equivalent matrices is that some matrices are computationally equivalent, meaning they have the same reduced row echelon form. And that's what we're defining as equivalent matrix in this case. And so an equivalent matrix to A would be multiplying A by 2, swapping the rows, swapping the columns. Those all should create equivalent matrices. And so you can see that if we run all of these checks, we get same matrix or equivalent matrix. And so the instructor's job is to pick the right function based on what they're looking for. Sometimes it's appropriate to have matrices, but sometimes because of different ways that students may solve problems, you might want to do equivalent matrix just to make sure that they've got the right thing. And that is the AnswerCheck function inside the AnswerCheck library. I really hope you'll use it, and have a good one.